If you want to follow along, you can pip install DataSpire. That's the library we're going to be using. If you've installed it already, but haven't upgraded in the past day, go ahead and upgrade it because I put some changes that will affect this talk. I'm Adam Hajari, data scientist at the Next Big Sound team at Pandora. And oh, I forgot to say, if you want to follow along with this notebook, here's a link to it. You can either just follow along through your web browser or download it and open it up in IPython notebook. All of the examples that I'm doing can't really be run from my Python notebook, so it doesn't really matter if you just look at it in your browser. So I'm talking about building simple data-driven web applications. This whole talk is going to be about the Spire library. There's a few other options. Bokeh has great tools for doing very similar things. But Spire is a library that I built, so I actually know a little bit about it. So that's what I'll be talking about. It was inspired by a similar library for R called Shiny. And so that's been around for a few years. And when I started this project, there were less options for doing the stuff in Python. So that was the motivation for doing this. So it doesn't have very many dependencies. Cherry Pie is what it's using to actually serve up your web app. Jinja 2 is doing some templating stuff. And then all the data stuff is matplotlib for your plots and pandas. And so matplotlib and pandas can be kind of a pain to install. So hopefully everybody's used Anaconda to take care of those dependencies. And if you have, then pip install DataSpire. It should work just fine for installing everything else. So let's get started. This is going to be a very example-driven. Sorry, go ahead.
So the URL of the URL for this topic. Can you show the URL of this topic?
I can't hear you.
URL.
Oh yeah, sorry. Briefly, it's PyData 2015_Spire. Okay, so this is going to be a very example-driven talk. I'll be just doing some live coding and kind of loading some of these apps real time. Can everybody see my text editor over here? I can make it a little bit bigger if you can't see it, raise your hand, let me know. I'll bump up the size a little bit more. Okay, so let's just start with a simple example. Your import is always going to be from Spire, import server. That server has an app class. So if we create an instance of that app class, it has a launch method that we can call. And if we run this, oh geez, that's loud. It launches a server. It tells us where it's being served from. Right now, it's just serving it locally. And if we put that in our browser, then we have an app. There's nothing in it yet. We'll add that in a second. In general, you'll want to create your own app class. So let's do that. We'll call it simple app. And it's going to inherit the server app. So we need to override a few of the attributes and methods for the server app. We'll get to those one at a time. We'll just start by giving it a title. And we save that and refresh. And we need to create an instance of our app. So now this is an instance of our app, and it has the title that we've given it. So let's give it a few more things. We'll start by giving it some inputs. So the inputs is going to be a list of dictionaries. The dictionary is going to define the attribute for each of the inputs. So we'll start with just one input. It'll be type text. for a text box. And it needs a key. So we'll just call it words. So if we reload, we have a text box now. We can give it, define a few more attributes. Give it a label. And a default value. Okay, so let's move on and add some outputs. The outputs come in two parts. We'll first need to define the attributes of the output by defining an outputs dictionary, just like we did with the inputs, or a list of outputs dictionaries. And so we're going to start with just an HTML output. And then each of our outputs needs an ID. So we reload. Now we have an HTML output. We haven't defined the content of this output yet. By default, it tells us that in order to define some content, we need to override the getHTML method. So we'll do that. And this takes one parameter, one variable called params. Params is how the inputs talk to the outputs. So the outputs are going to get the values that they need to generate their content from the inputs through this params. Params is a dictionary keyed by whatever key we specify in the input dictionary. So for instance, to get the words that we put on our text box, we just get it from the params dictionary. Each of the different output types and the corresponding methods expect a different return type. For getHTML, we're just going to return a string. Okay, now if we reload our app, our output is getting the value from our input and using that to display the HTML. This is HTML, so we can also add some HTML tags. Okay, we're not quite done. This is still a static page. We can change the input, but it does nothing to update the output, and that's because the output doesn't know when it's supposed to update. So there are two ways we can tell the output when it's supposed to update. We can add a control such that when the control is triggered, it tells the output, hey, check for new inputs and update. And we'll look at that approach first. So controls, like outputs and inputs, are just a list of dictionaries. We'll just make a button. And this needs an ID as well. We'll call it button 1. And it needs a label. So we reload this, we've got a button. It doesn't do anything yet because we haven't connected this to the output. So in order to do that, we need the output to reference the control that should trigger its update. So we define the control, ID, attribute, and just make it match the ID of whatever control we want to link it to. Okay, and now if we update our input and press the button, it updates our output. The other way you can update outputs is directly from the inputs. So this is a pretty simple app. It's a little bit overkill to have a button. Let's just have it so that when we change the state of the input, it updates the output. And we can do that through the inputs action ID attribute, which can actually reference either an output or a control. So the action ID here is going to point to our single output, which has ID HTML. I'll leave that there. All right, and now if we update the state of the input and press enter, then it updates the output. So just two different ways to accomplish the same thing. And they have different benefits depending on what your app looks like. So in this case, it's a simple app. Just changing the input is fine for updating the output. If you have a more complicated app where it takes a long time to load your data for your output, for instance, maybe you want to wait until you have all of your inputs set before you start the loading process. So in that case, a button might make some more sense. With a text box, the change in state is actually triggered by pressing enter within the text box. Other input types, like a slider, for instance, will just, that gets triggered whenever you change the state of the input. So that's going to be true with like drop-down menus and checkboxes. Changing the state of the output, of the input, triggers whatever's pointed out with the action ID. Okay. Let's just reference this notebook. I've got a few diagrams that kind of show the relationship between all of these elements. So in our first example, when we had inputs, outputs, and controls, the control ID is referenced by the control ID of the output, and then the output's parameters are just pulled from the key, or from whatever the value is of the inputs, keyed by the key attribute. And then when we took out that control, we referenced the output directly from the action ID of the input. So this is a very simple example, but it has all of the basic components of any Spire app you build. It has inputs and outputs. It's got the methods that you use to generate the actual output, and then it has controls as well if you want to add those. Let's look at a slightly more interesting example. Let's suppose that you wrote a function to go out on the internet and collect some stock data and put that into a pandas data frame. Okay, so this method takes a dictionary called params as a key ticker, and then the value is what it's going to use to actually determine which stock to go get. So in this case, we're going to go get stock data from Microsoft. So we run that. We get a pandas data frame with close, high, low, and open prices. If we were to change this to something else, we get data for that particular company. So we want to put this into a Spire app. So we're going to start with a text input. We'll key it off of the ticker, label it with ticker symbol, and then the starting value can be MSFT. And then we'll start with just a table output. So the table, or the output type will be table. We'll just give it the ID table. And we'll just, for now, keep the control button to trigger the update of that output. Okay. If we were to just save this and reload. The inputs, as expected, the output tells us that we need to override the getData method to generate our table. So conveniently, the function that we created to go get this data is already called getData. So we can almost copy and paste this over here. And then we need to make sure we include all of our imports. All right, now if we reload this, we get a table with all of the data we've pulled from the web. Oops. We can change the input, and that changes the data. So this is returning a Pandas data frame. And one of the really, really great things about Pandas data frames, my favorite feature, is that it's super easy to create visualizations directly from the data frame. Each data frame has a plot method that you just call, and it generates a plot. I'll show you how that works here if you haven't seen it before. This is the data frame that we created up here just by pulling that stock data. And if we call the plot method on it, it just plots the data. It's so simple. So we're going to take advantage of this and add a plot to our web app. So we need to define another dictionary for the new output type. This is going to be type plot. We'll give it an ID. The one on the right, yeah, this is the IPython notebook that I referenced at the beginning of the talk. I'll go back to the link one more time. This bit.ly link goes to that IPython notebook. I'll just leave it up for now. Okay, and then we want it to update whenever we press that button, so we'll give it the control ID button 1. I'll refresh our app, and we have a plot. You may be thinking, well, doesn't plot have a method that we need to override? And the answer is yes, it does. It has a getPlot method, but the default method for server.app says look for a getPlot method. If it's not there, then look for a getData method, get a data frame from that method, and then call the plot method on that data frame and return that. So if we wanted to do something different, like maybe we wanted to actually have date as the x-axis here, we could do that. We could just add the getPlot method. And then we'll take advantage of the fact that we've already written a method to get the data. And then we could just return this is basically what's happening if you don't do anything by default, if you don't define a getPlot method. We're just going to set the index to date. So if you set an index for a data frame, then the plot method will use that index as the x-axis for your plot. So you could also, in the same way, could have this as an object, and I think it has a set title method. Up here, we define the company name. That was part of what we got back from the API we were hitting. So I think we can just do that to add a title to this. No. So I'll cheat a little bit and see what I actually did. Oh, I actually have to return this. There we go. So you could do the same thing by adding labels for your axes and setting all types of attributes for that plot object. The plot object is actually like I think it's a matplotlib axes object. So you can either have your getPlot method return that, or a plot figure object, a matplotlib plot figure object. So whichever one of those is more convenient for you, it's just a matplotlib object.
Sorry, is the getPlot specific with that plot, or if you had multiple graphs, would it have different?
I'll get to that in a second, yeah. Towards the end of the talk, I'll talk about how to do multiple outputs of the same type. Let's also spice things up a little bit and use a drop-down input. All of this stuff can stay the same, but a drop-down has options, so we need to define an options dictionary. So the dictionary here is going to be a list of dictionaries, one for each option. And they need to have a label and a value. And the value is what actually gets passed to the whatever method is using this thing. Okay, let's add a few more of these. All right, so we change the input, and we get a new output. So we could actually still have the input update the outputs directly. The input only has one action ID, so we can't reference both of the outputs directly from the input, but we can reference the button. So we can have the input reference the button, and then when you change the state of the input, it's as if you're pressing the button. So if we added an action ID here, and had it point to our button control. Now changing this input is equivalent to pressing the button. Having the button is pointless now. You never need to press it. So we can actually use the control type hidden. You still need a control to change multiple outputs with a single input. But you don't actually need a physical control. All right, and finally, the outputs can get a little bit cluttered here if you have more than one, especially if you have more than two. So we can organize a little bit by adding tabs. So tabs is just going to be another list. In this case, it's actually just a list of strings, the title of the tabs. So we'll have a tab for our plot, and another tab for our table. And then we just need to specify in the output dictionary what tab each of these should go into. Great. So now we have a tab for our plot and another tab for our table. So a diagram to show how this slightly more complicated situation works. You've got an input that references a control, and that control is being referenced by two different outputs. And then if you had multiple inputs, let's say you had 20 inputs, all of those input values would be passed to all of your plots. So you don't have to worry about specifying which inputs go to what plot. All of the plots get all of the input values. And again, those are passed through with this params dictionary. So there's a few more things you can try. Let's try another output type for dictionary for download. The type is download. ID, we'll just call it download. And we'll add another button for this particular action. And it doesn't need to go in a table or in a tab. So let's add a second button for our download action. Okay. By default, all of these outputs will load when the page loads. So you see that as soon as I loaded this page, I downloaded whatever it was I was downloading. We usually don't want that behavior with downloads, so we can specify another attribute called on page load and set that equal to false. All right, and now when we load this page, we have the download button, and when we press it, we get a CSV. We open this. That's just the content of our data frame. So just like we saw with the plot, we don't need to specify an output for the download output. It will just by default pull whatever data we're getting from getData. If we wanted to alter that data before we passed it to the download, we could do that by overriding the getDownload method. But that's not necessary if you just want to download whatever's being passed from getData. Okay, also these tables can be sortable. You just need to specify in the dictionary that you want it to be sortable. So there's a sortable key, and we can just set it to true. So now we can sort this table by all of its fields. I'll mention that I'm not going to do a demo for this, but there's a couple of great JavaScript-based Python plotting libraries. OK is my favorite. Vincent's another good one. We have the getHTML method. We have the HTML output. Both of those libraries can output HTML, static HTML, that you can use to generate JavaScript-based visualization. So if we go back up to one of these live examples we've got, we'll look at this one. This is what we just, a version of what we just generated, but this also has a bokeh plot. And so if you haven't used bokeh before, it's awesome. It's interactive. You can scroll and zoom. So it's a great plotting library, and you can integrate this directly into your Spire app. Okay. Oh, also in this example, we can link our inputs such that when we make a change to one input, it will be reflected in another input. So for instance, if we change, let's say we had a stock that's not in this list, so Microsoft isn't in this list, and we wanted to give our users the ability to specify another company, we could do that, and that changes the company drop-down menu so that it isn't confusing that it still says Google when actually we're looking at Microsoft data. Or if you were to select Google, it changes the value there. So those are just kind of a few extra features of Spire. It's fairly straightforward to deploy a Spire app so that somebody that's not looking at your computer can see it. Heroku and Python Anywhere offer free options for that, and I have a blog post on how to set that up with Heroku. DigitalOcean is a great option too. They have plans for $5 a month, and in fact, this app is being hosted on, oh, not this one. This app is being hosted on DigitalOcean. This is another app that uses the bokeh plotting library. So it has the ability to kind of zoom in, but it also has tooltips, which is great. And then you can also host on AWS, which is like about $10 a month if you have no traffic coming to your site, but who knows. So yeah, there are other input types, other output types. The best way, I think, to figure out how to use all of this is just to look at the examples, which there's a number of examples in the GitHub repo. Hopefully the documentation will beef that up a little bit soon to talk about all of the different things you can do. Yeah, oh, and somebody asked about what happens if you have multiple outputs of the same type. So let's say we wanted to add another plot. We'll just copy and paste this one. So type plot, it needs to have a unique ID, so we'll call it plot B. And we'll put it in the same tab. So if we were to update this, we've got two plots now, but they're both using the same getPlot method. So the workaround here is that you can actually, rather than overriding one of the built-in methods from the server.app class, you can also use you can name your method whatever your ID is. So if I were to call my second plot method plot B, that's the ID for the second plot. It takes the same values and we'll have it generate the same thing but with a different title. Oh, what we actually have to do is we can't use the getPlot method and the custom naming method. We have to name both of our plots using the IDs. Okay, so now we get two distinct plots, and we could do this with any number of outputs of the same type. Cool. That's all that I've got. Do we have time for questions?
We do have time for questions, but it's also lunchtime, and lunch is out in the main hallway, so if you'd like to go get that, you have about 45 minutes before heading into the keynote room for Van Lindbergh. If you do have any questions, then feel free to hang out here and chat with Adam for a bit. Let's thank Adam for a great session.